Okay, so hello and welcome to this video tutorial for V411, statics and dynamics of simple mechanisms. So we have this problem here. It states the minecart and its contents have a total mass of 6,000 kilos and a centre of gravity at G. If the coefficient of static friction between the wheels of the tracks is 0.4 when the wheels are locked, find the normal force acting on the front wheels at B and the rear wheels at A when the brakes at both A and B are locked. Does the car move? Okay, so this is quite a wordy question, and there's quite a lot to unpack here. I've gone ahead and drawn the geometry of this problem beforehand, and I'm going to add the forces to it to make it a free body diagram here. So I might add the weight. Oh, Microsoft does not like that. There we go. Didn't like that either. There we go. Right. So we have this weight force here. We can describe it as 6,000 G, since it's given that the mass of the minecart is 6,000 kilos. What other forces do we have? Well, we have this external force here of 10,000 kilonewtons. Sorry, 10,000 newtons. I'm going to describe it as 10,000 newtons instead of 10 kilos, just because this 6,000 G is in newtons here. And the reason that this minecart is not accelerating through the floor is because of these normal forces between, or these contact forces rather, between the wheels and the track. So let's add them there. And to counteract that 10,000 Newton external force, there are these frictional forces, which I'm going to describe as FA and FB. Okay, so what many of you may be familiar with already is this idea of resolving vertically and horizontally. Let's apply this idea to this problem. So we could, when we say resolving vertically and horizontally, we're saying we're adding together all the forces vertically, or we're adding together all the forces horizontally. So we can say, or we can assume that the sum of the forces in the y, or vertically, are equal to 0, because as I mentioned earlier, this minecart isn't accelerating into the floor or isn't accelerating into the sky. Vertically, it's staying put, right? So we can say the resultant force in the vertical is 0. Therefore, 0 is equal to the things acting up, so NB plus NA minus the things acting down, so that's 6,000 G there. In terms of the horizontal, well, it's not stated if this is in equilibrium. In fact, it's asked, does the car move? So what that's asking is, what is the value of this? So we can't really just assign a value to it right away, but we can still say the sum of forces in the x direction is equal to things moving to the right. You've got FB and FA, and the minus things acting to the left, so minus 10,000. So I've resolved vertically and horizontally here. I have NB and NA are unknowns in this vertical equation here. This is unknown. This FB and FA are unknown. However, we understand that frictional force can be taken as, F here I'm just using to denote friction, can be taken as the coefficient of static friction times the normal force at the point of contact. So I could describe this equation here alternatively as we understand that mu s is 0.4 from the question. Shall I just write 0.4? I could just say 0.4 times NB plus N A minus 10,000. So let's consider this to be equation 1 and this down here to be equation 2. Oh, my handwriting. Okay. How many unknowns do we have? We have 1, 2. That's the same as that and that. 3 unknowns, right? We have 3 unknowns. If we have 3 unknowns and 2 independent equations, then we have more unknowns as we do independent equations. The problem is not solvable at the moment. It's underspecified. Okay. In other words, we have 1 degree of freedom, understanding that we have 3 unknowns and 2 independent equations here. So it might make sense then to determine a value for one of these unknowns, right? Well, how we can do that is, in the context of this problem, is we can take what's called a moment, and I should have other content out that talks about moments, which hopefully should be linked on your screen now if you're unfamiliar with the idea. I'm not going to repeat the ideas that hopefully I'll have explained in that video. I'm just going to go ahead here and take moments about point A, where point A is this point of contact here between the wheel and the tracks. I'm going to say this is equal to 0, assuming that the wheel isn't moving. Okay, therefore 0 is equal to the things moving it clockwise, which in this case will be 1.5 NB, minus the things moving it anti-clockwise. So that will be 1.05 times 10,000, 10 to the 4. Minus 0.9 times this 6,000 G. 0.9 coming from this 1.5 minus this 0.6, which gives us that length there. So minus 0.9 times 6,000 G. Okay. Is this solvable? Yes, because we've only got one unknown in it, right? NB. So let's rearrange for NB. We find that NB is equal to 1.05 times 10 to the 4 plus 0.9 times 6,000 G all over 1.5. So I've just added these two terms to both sides and then divided by that 1.5, which gives me a value, which I've written down somewhere here, of 42,300 newtons. So I'm just gonna call it 42.3 kilonewtons. Okay. And now that I have NB, going back to this vertical equation that I defined at the start, we understand that NB plus NA minus 6,000 G is equal to 0. So I could determine NA. I could say, therefore, NA is equal to 6,000 minus NB. 6,000 G minus NB, which I'm going to describe as 42,300. Which is equal to, I've written it down here, it's 16.5, or roughly 16.5 kilonewtons. Okay, so I have NA and I have NB. Now that I have NA and NB, I can determine the answer to this portion of the question, does the car move? In answering this question, does the car move? Let's first understand how we're going to interpret this value. So we have the resultant force in the x direction. Basically, one of two things can be true. Either the car is moving or the car isn't. What value would we expect to get if the car is moving? Well, the value we would expect to get if the car is moving is would be negative, right? Why would it be negative? Well, if the resultant force in the x is negative, that would mean that the resultant force is acting in the left direction, and obviously the left direction is the direction in which this external 10,000 Newton force is being applied. If it's positive, implying it's moving in or that the resultant force is acting in the right direction, then that would imply then that this 10,000 Newton force is insufficient to kind of breach these frictional forces at A and B. Okay, so if it's negative, the car is probably moving. If it's positive, this 10,000 Newton force is insufficient to breach these frictional forces, and the car is not moving. Okay, so let's go ahead and carry out that calculation then. We can say then that the sum of the forces in the x direction is equal to 0.4 times 42.3 thousand, 42,300 plus 16,500 minus 10,000, which is equal to, I don't have this written down, so let's put it in my calculator. 0.4 times 42,300 plus 16,500 minus 10,000. That gives 13,000, or 13.5 kilonewtons roughly. Okay. Now, since this value is positive, what that would suggest then is that the car does not move. Okay, so that's the answer to our problem here. If you have any questions or points, feel free to raise them in the comments. Otherwise, thank you very much for watching.